Okay, Unit 4, Video 4, we will be solving rational inequalities. Make sure you've got your notebooks ready. Here we go. So we are going to solve this inequality and write our solutions in interval notation. Okay, so while you may think, let's just cross multiply, that actually causes a problem with solving an inequality that is a rational expression, because we could be missing the other side of it where it's negative. If you can imagine, like our parabola that went below the x-axis and so on. So what the best thing we can do here is get it equal to 0 and then follow a few steps after that. So let's go ahead and subtract 1 to the other side. So I have 5 over x plus 4 minus 1 is greater than or equal to 0. I want to combine everything on the left-hand side here, so I'm going to get a common denominator of x plus 4. So that will leave me with 5 over x plus 4 minus 1 times x plus 4 over x plus 4. Still greater than or equal to 0. Then I will go ahead and distribute this negative 1 and clean up my numerator so that I'm combining these into one rational expression, which will leave me with, let's see, 5 minus 1x minus 4, so I will have 1 minus x over x plus 4 is greater than or equal to 0. You might be thinking, how is this any better? We're going to take a look together at the graph of this when we're in class, and we're going to talk more about why this was a good way to do it. So I want you to go ahead and just follow through some of the mechanics of this with me. The first thing we're going to look at is, where is the numerator equal to 0 and what causes the denominator to be undefined. So where are we going to be undefined? And then where is the numerator equal to 0? So as far as the numerator goes, the numerator is equal to 0 at x equals 1. And our denominator is equal to 0, which causes this rational expression to be undefined, at x equals negative 4. These are going to create the intervals in which we're going to test. So I'm going to draw a number line, and I'm going to place on it negative 4 and positive 1. Now when our numerator is equal to 0, that's okay, because I'm allowed to be equal to 0 because of this symbol right here. So on 1, I'm going to put a closed circle. However, on negative 4, if this were to equal negative 4, if we were to substitute in a negative 4, even back in the original problem, we would have an undefined situation. So I'm going to put an open circle. So to determine whether you're using an open circle or a closed circle, substitute this value back in and see if we're going to get a true statement or something that's undefined, not allowed, what's going to happen. So substitute these values back in to determine the open and closed. Now we're going to be looking at a few intervals. So my intervals here go from negative infinity to negative 4. I'm using a soft bracket. From negative 4 to positive 1, that's a closed hard bracket. And from positive 1 to positive infinity. Now that's just following this number line. What we're going to do is we're going to test those intervals. So first thing, we're going to pick a number that falls on that interval to be our test value. I'm going to choose negative 5. I'm going to choose 0, and I'm going to choose 2. I'm going to test those. If I get true, it's part of my solution set. If I get a false, that interval is not part of the solution set. I'm using the negative 5 to represent any value that falls in this interval. So let's go ahead and substitute in negative 5. 1 minus a negative 5. Oops, sorry, excuse me. We're going to go back and use the original situation here. So go back up there. It'll be less complicated. 5 over negative 5 plus 4. Is that greater than or equal to 1? When I substitute it in, I get a false statement. Next interval, I'm substituting in 0. 5 over 0 plus 4. Is that greater than or equal to 1? That is true. Substitute in 2. 5 over 2 plus 4. Is that greater than or equal to 1? That is false. So the only interval in which I got a true statement was from -4 to +1. This will be our solution set. Let's try another one. Okay, for this example, we're going to do very much the same steps. We're going to subtract the 5. We're going to find a common denominator and write that as a single expression. First step, subtract the 5. Now it is less than 0. Next, we're going to find a common denominator. Our common denominator is 3x plus 4. 2x minus 1 and 5 times 3x plus 4. I'm going to distribute and write this as a single expression. 2x minus 1 minus 15x minus 20. As a single expression, this is written as -13x minus 21 all over 3x plus 4, and that is less than 0. As we did on the previous example, we're going to take a look at our numerator and decide where it equals 0. So the numerator equals 0 at -13x minus 21 equals 0. This will give me 21 over -13, or -21 over 13. And this is going to be an open circle. I'm going to use an open circle because if I substitute in that -21 over 13, it will equal 0. And because of our inequality symbol here just being a less than, I don't want to equal 0. The denominator equals 0 at -4/3. That has to be an open circle because it is the denominator. If we substitute in -4/3, we will have an undefined situation. So I again have two places to put on my number line. Which of those numbers is smaller? Well, it's the -21 over 13. They're both open circles. And let's go ahead and write our intervals from -infinity to -21 over 13, both soft brackets. From -21 over 13 to -4/3, soft brackets. And from -4/3 to +infinity. I'm going to choose a value to test. On the first interval here, I'm going to test -2. I'm going to choose a different color so we can see all this on here. So I'm going to test here -2. In between here, I'm going to test -1.5. You're going to have to do some figuring to decide what the best values to test are. And then over here, I'm going to choose 0. If there's an interval that includes 0, I am definitely testing it. I can't test 0 if it is one of the values on my number line, like the borders of my intervals. That's the only time I cannot test 0. Otherwise, 0 should fall in between somewhere since it is on the number line. Alright, now we're going to go ahead and substitute in those values and determine which intervals are true and which ones are false. Those that are false are not part of our solution set. So I'm going to do 2 times -2 minus 1. Remember, I'm going back to the original expression up here. 3 times -2 plus 4. The question is that less than 5? When I clean this all up, I'm left with 5 halves is less than 5. That is true. On this other one here, the center one, I'm going to have 2 times -1.5 minus 1 over 3 times -1.5 plus 4. When I clean all of that up, I should end up with 4 over 0.5, which is 8, which is, not less than 5. That is false. And the last one, 0, what a nice one to substitute in. 2 times 0 minus 1 over 3 times 0 plus 4. That gives me negative 1 over 4 is less than 5, and that is true. So in this case, I have two places that are true. Two intervals across our number line, across all real numbers, are true. So that's going to present to me a union. Negative infinity to negative 21 over 13, union with negative 4/3 to positive infinity. These are the solution sets that work for this particular inequality. I've got one more for us to try. Alright, this one is already have a 0 on the right hand side, so we don't have to move anything over, which means we're ready to start at the very beginning and determining what we want to test. So I've got my numerator equal to 0 at positive 8/9. My denominator set equal to 0, well, it's never going to be equal to 0. I'm never going to have, well, it will be equal to 0, not on the, take that back. It's not going to have any restrictions on the real number line. So therefore, I'm not going to be concerned with any restrictions. So no restrictions at all. Which means the only place I'm testing is on either side of 8/9. To determine whether or not this is an open circle or a closed circle, if I were to substitute in 8/9 back in the original problem here, I would find that at 8/9 this fraction simplifies to exactly 0, and I'm not allowed to equal 0 because I don't have that in my symbol. So this must be an open circle. So my intervals here are from negative infinity to negative 8/9. Did I say negative 8/9? We should be at positive 8/9. I don't know where that came from. Let's get rid of that. And on the other side of this is 8/9 to positive infinity. So we're going to test in two places. We're going to test at, how about at 0 over here? And on this side, we're going to test at 2. Let's go ahead and substitute this in. So on over here, if I do 9 times 0 minus 8 over 4 times 0 squared plus 25, the question is that less than 0? Well, the numerator is negative and the denominator is 25, so this is less than 0. This is true. Let's go ahead and test on the other side. I'm going to substitute in 2. 9 times 2 minus 8 over 4 times 2 squared plus 25. My numerator is going to be negative 10. My denominator is positive. I'm not even concerned. This is going to be less than 0 because my denominator is positive. Therefore, it's less than 0. This side is also true. So this is kind of something where you don't have to actually follow through and finish this portion of it because you recognize that it's going to be positive. Okay, that's kind of a little bit of intuition there. Now what happens here if I have all of the values on both of these intervals to be true? Well, it doesn't mean my answer is all real numbers because I was not allowed to have x equal 8/9. So that's the one place that doesn't work. So I will still have to write this as a union because of this being an open circle. So from negative infinity to 8/9, union with 8/9 to positive infinity. That is my solution set. Please try these 5 problems. The first 3 are going to be a little simpler, and then we've got the last 2 to be with the denominator being a little bit different for you. Please try them so we have somewhere to start tomorrow in class. Thank you.